Hello students, welcome. Previously, Form 4, Topic 2, Lesson 11, we were doing Hess's law using the flip formula. We have done example 1. So today, Lesson 12, we are going to do example 2. So the question is, we are told, use the enthalpies of combustion below. So here we have combustion of ethanol, we are having a combustion of hydrogen, and we have here combustion of carbon. And these are the heat change or the enthalpy change, or these are called the standard enthalpy of combustion of ethanol, and this is the standard enthalpy of combustion of hydrogen, and this is the standard enthalpy of combustion of carbon. So the question is, you are told calculate the enthalpy of formation of ethanol. So using the flip formula, you are supposed to know your demand question. The demand question here is formation of ethanol. So formation of ethanol, what is enthalpy of formation? Enthalpy of formation is the enthalpy change that occurs when 1 mole of a substance is formed from its constituent elements in their standard form. So ethanol, the elements forming ethanol are carbon, which is solid, plus hydrogen, which is a gas, plus oxygen, which is also a gas. This all will give us ethanol, C2H5OH. Ethanol is a liquid. So let's balance the question. We have 2 carbon, we put 2 carbon there. We have 6 hydrogen, we put 3 hydrogen there. Then we have 1 oxygen, that means we put half of oxygen there. So this one is our demand question. This is the demand equation. The demand equation. So using the flip formula, we are supposed to use our demand question to calculate the enthalpy of formation of ethanol. Okay, we have here 2 carbon, and the thermochemical equation given, the 3, one of them is having carbon, which is solid. But here we have 2 mole of carbon. So what we are supposed to do is, we put the whole equation 2. Then we remove the bracket. So multiply this 2, the whole thing that's in the bracket. So we get 2 carbon, solid, plus 2 of oxygen, gas. Then we have arrow, we get 2 of carbon dioxide, gas. So the enthalpy change here will be negative 786 kilojoules per mole. You are supposed to also multiply the standard enthalpy of combustion of carbon by the 2. Okay, next, here we have hydrogen gas, 3 mole of hydrogen gas, and this is the thermochemical equation that has that hydrogen gas. So you put bracket, then you multiply by 3. Then we are going to get 3 of hydrogen gas, plus we're having 3 out of 2 of oxygen gas. We are multiplying this 3 by this half. So arrow, we are going to get 3 mole of water, which is liquid, and the enthalpy change here multiplied by 3 will be negative 858 kilojoules per mole. So lastly, we are having here ethanol, but ethanol is on the product side, but the ethanol that we have here is on the reactant side. So what we are supposed to do is, we flip this equation, or we reverse the equation. Okay, if we check the mole of ethanol that we are supposed to have is 1 mole, so here is 1 mole. So there's no need of multiplying by 2 or 3. So you flip that equation, or you reverse. Okay, what do we mean by reverse? That means you take your product and you make it as your reactant. So we have 2 mole of carbon dioxide gas, plus 3 mole of water, which is liquid, arrow. Then there we are going to get ethanol, C2H5OH, which is liquid, plus 3 of oxygen gas. So the sign will also change. If it is minus, it's going to become positive. If it was positive, it will become negative. You are supposed to also change the sign. You reverse the sign, 1368 kilojoules per mole. So last step, let's just try to check our our equations, the equations that we have formed now, the three equations that we have used our black pen. Then if you see a substance on the reactant side, if you see on the product side, you are supposed to cancel it. You eliminate it. So 2 of carbon dioxide gas will go with 2 of carbon dioxide gas on that reactant side, because these 2 carbon dioxide are on the reactant side, these 2 mole of carbon dioxide are on the product side. So check again. Here we have 3 mole of water on the product side because the arrow is here, and here we have 3 mole of water on the reactant side. So we are going to eliminate them. So they go together. That means we are going to remove together. So next, if we check, we are going to remain with 2 carbon. This is 2 carbon. The 2 carbon is here. So the oxygen that we have, we are supposed to add them. So check hydrogen. We have 3 mole of hydrogen gas. These are the 3 mole of hydrogen gas. So let's check now. Here we have 2 of oxygen gas plus add that 3 out of 2 of oxygen gas. So that one will give us 3.5. It will give us 3.5 of oxygen. But if you check on the product side, I have 3 of oxygen. So you are supposed to remove 3 of oxygen on the reactant side so that you remain with 1/2 of oxygen. Because on the product side, we are having 3 of oxygen gas. But on the product side, we have 3.5. So that means you just take 3.5, then you subtract 3, you're going to remain with 1/2 of oxygen gas. So that's the oxygen gas. And on the product side, I'm remaining only this ethanol because this oxygen gas has gone with these 2 and also 1/2 of that. Okay, so we are having the ethanol here. That means the last step, you are supposed to add what you have gotten on these 3 equations. After doing the Philippine formula, you are supposed to add these 3. So if you take positive 1368 kilojoules per mole, then you add negative 858, then you add negative 786. The enthalpy change that you are going to get will be negative 276 kilojoules per mole. So what you have gotten here will be the standard enthalpy of formation of ethanol. And that's the question that we ask. Calculate the enthalpy of formation of ethanol. That's the end.